Brown's University and ASM. Thank you for inviting me to speak at the Gut Health Summit. I'm Sarah Berry. I'm an Associate Professor at King's College London, and I'm also the Chief Scientific Officer at ZOE. And I'm going to spend about 10 or 15 minutes talking about what I think is a really exciting time in nutritional research, because there's a real paradigm shift in how we can conduct nutritional research that's also applicable to all biological research. And you'll see at some point why this is relevant to the Blue Poo Challenge that I'm hoping many of you will also do. So we have a problem. We have a problem that diet-related diseases are exploding, that we know that millions and millions of deaths and life quality days are lost due to diet-related diseases that could be preventable. And we need to ask the question, why is this? Is it because people simply don't follow the advice? And in the UK, this is a real problem, that less than 1% of people actually follow all 7 of our dietary guidelines. Or is it that for even those people that are following the advice just isn't fit for purpose? Now, I think it's actually incredibly complicated, and this is because food is really complex. And I know Tim touched on this in the earlier talk. Food is so much more than just its simple nutrients. It consists of thousands of chemicals encapsulated within a really complex matrix, and by this I mean structure. So we know that actually food is more complicated than we first really thought as nutritional scientists. Who we are is also incredibly complex, that we have so many thousands of biological pathways that differ between each and every one of us. But really importantly, we also now know that how we eat and why we make those dietary choices are really important. And by the how we eat, I mean what time of day we're eating, how much exercise we've done, how much sleep we've had, what we've eaten in the meal before. All of this impacts how we respond as individuals to food. And so it's really important when we're trying to disentangle and unravel the health effects of food, that we collect really high resolution, precision and breadth of data on food and who we are. But also we collect real-time data on us as our individuals, so real-time lifestyle data, so real-time data on what have we just done before, how much sleep did we have we just exercised, are we feeling stressed, what was our previous meal? And it's only when we have all of this data that we can really unravel what causes us to respond in a certain way to different foods. Now, this just hasn't been possible before, but we're in a really exciting new area in nutritional research where we can capitalize on citizen science, and I'll touch on this in a little bit when I talk about the Blue Poo work we've done. We can use digital tools, we can use AI and machine learning, and most importantly, we can combine all of this kind of novel approaches with the very traditional scientific approach that I, for example, have taken at King's College over the last 25 years of my research. And this enables us new ways of acquiring a vast amount of data. And so just to give you some context of this in terms of how I've traditionally done nutritional research, and the same applies for all biological research or most biological research. Previously, we've had the option of either relying on very high resolution, so high precision and traditional randomized control trials that are very low quantity. So I might run these kind of studies, for example, with 20 people, but they're very high precision. Or we've had the option of getting very high quantity, so large scale type of data from epidemiological and ecological studies, but there's really low precision, so quite low resolution. But we're at this really exciting time where we have these big data opportunities, and these have arisen from the opportunity to run remote clinical trials that give us this scale, breadth, depth, and precision. And this is because we can capitalize on novel technologies, we can capitalize on digital devices. And I'm sure the majority of you listening to this will have some sort of watch that might be monitoring their heart rate or their activity, or some sort of phone that does the same. We can capitalize on clinical devices, so continuous glucose monitors that you can fit from the comfort of your armchair onto your arm, for example, and it will continuously monitor your blood glucose levels, for example. We can also capitalize on other remote clinical testing. We can, again, from the comfort of our own armchair, collect swabs to collect data for DNA, or we can collect a poo sample to collect microbiome data, or we can do a small kind of finger prick sample to collect a whole host of metabolomics. But all of this really relies on citizen scientists. So people like you collecting data, taking part in these large science driven projects and sharing the data back with us as researchers, so that firstly you learn about yourself, but most importantly researchers and scientific advancements can happen at pace. And what this does is this allows us to go from a very general biological or general nutrition approach to a more stratified and ultimately a personalized nutrition approach. And you'll see why this is important in a minute. And this is exactly what we're doing with our PREDICT program of research. This is the world's largest ongoing program to measure individual responses to foods and nutritional science. It's a very unique collaboration between traditional academic institutions such as King's, where myself and Tim work, and other academic institutions in the US, and ZOE, who are a tech company who were specifically formed in order to undertake the PREDICT program of research to develop a personalized nutrition app and product. This is a summary of the PREDICT studies. I'm not going to bore you by telling you about all of the PREDICT studies. If you're interested in finding out more, you can go onto the Join ZOE website, which is joinzoe.com. Basically, we have three main PREDICT studies: PREDICT 1, PREDICT 2, PREDICT 3 study, and we're also doing some longitudinal research and also a randomized control trial. These are all large-scale, huge studies. So PREDICT 3, for example, is currently at around a level of about 35,000 people who have completed, and we're recruiting about 1,000 people a week for this. So it's really large scale. What's common for all of these studies is the remote clinical testing. PREDICT 1 was our first study that involved clinic and remote testing that I know Tim's talked about, but the PREDICT 2 and the PREDICT 3 studies are remote, exclusively remote studies that really allow us to start to disentangle what are the main determinants for us of how we respond to food between each individual. And this really allows us to push the fast forward button on biological research. And it's so exciting to be a part of all of this work. And what's really key to the work that we're doing, and it's really important for personalized nutrition, and what I think is really exciting about the novel technologies, is that they allow us to look at scale at the multiple determinants, or we also call them exposures, the multiple responses and multiple outcomes. And this is really important because we know that not in isolation, we know that they're very integrated and interrelated in how they shape how we respond to food. So we can't look at our glucose responses, for example, just in the context of the food that we've eaten. We need to look at our glucose responses in the context of also how much exercise did we have? How much sleep did we have? What was our preceding meal? What's our genes? Genetics makeup, what's our gut microbiome? And it's only by using all of these novel technologies, collecting data at scale, breadth and precision, that we can start to really disentangle this. And there's three main areas that I think are really important that we consider. And I've mentioned this in one of the earlier slides. We must think about what we eat, who we are, but also how we eat and why we make those choices when we're working on personalized nutrition and developing personalized nutrition advice. And the reason is because this allows us to go from the average, so to go from very average population-based guidelines, such as the MyPlate guidelines that you have in the US, to the individual precision nutrition plate, as you can see here, that's based on all of these different inputs, not just our omics that we often talk about, so like our genetics, our microbiome, and our blood chemical composition, but also our dietary habits, our food behavior, and things like physical activity, for example. But why do we need to go from the average to the individual? Well, I think we need to really think about how meaningful is the mean. Now, traditionally, in all of the research that I've conducted up until the last 5 years or so, I always present the mean response following a dietary intervention. But actually, there's a lot of variability. And should we be looking at the mean response, or should we be looking at individual responses? And I'm going to show you results from one of my colleagues, Christopher Gardner, who's based at Stanford in the US, from a long-term dietary intervention study he did, where he randomly allocated people to either a low-fat or a low-carb diet for 12 months and looked at weight change. And what you can see here on the left is that actually both diets resulted in approximately the same 6 kilogram weight change over the 12 months. But how many of us are average? If you look at the individual responses from this study, you can see huge variability. So what he's plotted here is each one of these blue lines or these purple lines is an individual's weight loss or weight change. And then what I've done here is put the mean, so this 6 kilogram in the red line for the low fat and here for the low carb. And what you can see is the mean actually is pretty meaningless for the majority of these people. So for the people down here that lose a lot of weight, they're responding very differently to the people over here on the right that are actually gaining weight on the low fat diet. And yet down here, again, you have the same difference where you've got some people where low carb diet is highly effective and others where it actually causes them to increase weight. And what this shows is there's huge individual variability in how we respond to food, and that actually we should be looking beyond the mean when we're presenting research, but also we need to be thinking about certain scenarios where alongside population-based advice, we might want to implement or overlay personalized dietary advice. And this is exactly what we're doing with the PREDICT program. We're trying to disentangle where we need to give personalized advice, how to deliver personalized advice, and look at the efficacy of giving this advice. And I know Tim presented some of these results, so I'm not going to go through them, but just to say that it's really exciting from this research that we can piece together this really complex puzzle of us as individuals by collecting all of this data, looking at all of the kind of exposures that I've put, for example, on the right, and we can start to look at what is really shaping individual responses to food and accounting for this variability like I showed you on the previous slide. Now, given that I know as a university you're going to take part in a Blue Poo Challenge, I really didn't want to finish this talk without talking about what we've done with Blue Poo and with our blue muffins. And as part of the study from PREDICT 1 and PREDICT 2, we fed people blue muffins. We fed them blue muffins in order to measure something called transit time, which is basically the time that it takes for food to go from your mouth and be excreted in your poo. And what we asked participants of our study to do is to log the time that they consumed their blue muffin and log the time that they saw it in their poo. And then logged for the duration that it still appeared in their poo. And we then measured and calculated the transit time, so the time difference between them consuming the blue muffin and it being excreted. And then we conducted some analysis to look at how differences in transit time might be related to the microbiome. And we published this in Gut only last year, and the key results are here, which shows in summary that actually measuring transit time from using something so simple as this remote blue muffin testing and people logging their time can actually tell us a reasonable amount about the microbiome. On the back of this, we actually launched something called our Blue Poo campaign, where we invited everyone all over the world to take part in measuring their own transit time. We either provided muffins to them or we gave them the recipe of how to actually make the muffins themselves. And it actually went viral. We had 32,000 people that took part in this that we know of, that logged their data. And it became viral on the internet. It was really exciting and on social media, and you can see some of the pictures of the right. It was trending at one point. It was even on Times Square in the big screens there. So it's a really good example, I think, of where something as serious as microbiome and transit time can be actually adapted and measured in a way that allows us to capitalise on citizen science in a really fun and engaging way. And what was great about this campaign is we were able to, in real time, give information back to participants on, this is your average transit time, this is the average transit time for your country, this is how your transit time is related to your diet, because these people log their diet. So I'm really excited that at Brown's University, you're going to be taking part in this as well, and really excited that we can add this to our data set. And this is some exclusive results that are only hot off the press last week, where we started to analyse this blue poo data from our blue poo campaign, where we have the data from around the world. So this is not just from our 1,000 people from Predict1, but from these 32,000 people. Once we clean the data, this is data on 21,500 people, and you can see that there's actually differences in the transit time depending on where people live. So what we can see is for the US, it's about 23.5 hours. So I'd be really interested to see what kind of transit time you'll get when you do this. And I'm really excited that you're going to be involved in some of this citizen science work that we're doing. What I wanted to do, finish up on, is illustrate another more serious way that we can use citizen science to really advance biological science and digital science at pace. Now, when COVID hit in the UK, it was very difficult to get testing, just like it probably was, I think, in the US. And so it was very difficult to identify the prevalence of COVID in the community. And so we decided at ZOE to use our AI expertise and launch something called the COVID symptom study. And this COVID symptom study was launched within 1 week of Tim Spector having the idea that what we should do is try and collect data on people's symptoms and then build prediction algorithms to see the likelihood of them having COVID based on their symptoms. And it was a really powerful message, I think, of the power that citizen science, the contribution that citizen science can make actually to some very serious biological scientific advancements. So within a week of launching this, we had 4.5 million citizen scientists that signed up to this app. And they logged every day their symptoms, even if they were well. And what we were able to do is we were able to look in real time across different regions of the UK, which you can see here, the prevalence day to day of predicted COVID. And so a certain number of people were getting tested, and we could use the cluster of symptoms for those that were actually getting tested and were positive to predict those that were unable to get tested, whether the likelihood of them being positive was high or low. And it also enabled, way before all of the testing got implemented, the government to be able to see where their hotspots were and to be able to implement suitable precautions. We've since carried on with this COVID symptom study and have really great data on everything from comorbidities, the effect of exposures, mask wearing, affected long COVID, also about diet, quality habits and lifestyle, how it all impacts our chances of getting COVID and severity, and so much more. And we've now converted the COVID symptom study app to the ZOE Health Studies app. And it's now this citizen science platform that allows us to collect high scale, really large scale data to make meaningful changes, I think, in how we can conduct research and the pace at which we can conduct research. So what's the future for nutrition methodology? Well, the past, as you can see here, which is a real picture of an old nutrition study, is way behind us, fortunately. There is a place for very in-depth metabolic feeding studies still, but I think that the future is really exciting. The present, as you can see, is where we can use these kind of remote technologies that we talked about, remote clinical testing. But I think that the future really lies in us being able to collect real-time data, enabling us to collect data on what people are doing there and then, and give advice based on the context of how they're living their life at that particular point in time. So I would say watch this space. I think that there'll be significant improvements within the next year or so. And I'd say thank you very much to inviting me to be part of this Gut Health Summit, and enjoy your blue muffins. Thank you.